Hi, I am Syed on Maths Online. Today we will be dealing with the topic of the solution of homogeneous differential equation subject to given condition. So let us take the first question. Solve y double dash plus 4 times of y dash plus 4y is equals to 0, given that y is equals to 0, y dash is equals to minus of 1 at x is equals to 1. Let us write this differential equation in the form of the operator. So this becomes d square plus 4 times of d plus 4 times of y is equals to 0. And if I write down the auxiliary equation will be m square plus 4 times of m plus 4 is equals to 0. You can factorize this auxiliary equation, or you can use the calculator and try to obtain the roots of this equation. If you want to use the roots using the calci, then if you just go for mode, so under mode you have equation, that is 5, you can just press it. Then you can choose the quadratic equation. So the quadratic equation is nothing but option 3. So you can choose option number 3. So option 3 you can choose. Then just write down the coefficients. So what are the coefficients you have? Coefficient of this m square that is there is 1. Then coefficient of m is 4. Then the constant term is 4. So you can just type in 1, 4, 4 to get the roots. So I'll just type it 1, press equals to, then 4 and press equals to, again 4 and plus equals to. Once again you press equals to sign, you can see the root. So that's the first root you have. X is equals to minus 2. Since it is showing only one root, that is x is equals to minus 2, it is understood that the root is repeated twice. So if it shows only once, because it is a quadratic equation, it should have two roots, which means this minus 2 is being repeated twice. So that will be the root of this equation. So either you factorize or you use your calculator to get the roots. So once you got the repeated roots, you can write down the complementary function. So because it is a homogeneous equation, your complementary function itself will be the solution. Y is equals to, it is c1 plus c2x into e power of minus 2 times of x. So that's the solution we have. But further he has given this conditions. When y is 0, y dash is minus of 1 at x is equals to 1. So let me take this as equation number 1. So let me take the condition at x is equals to 1 and when y is 0. So when y is 0 and x is 1, what will be this equation? So equation 1 implies, so y is 0 over here, you have c1 plus c2, x value is 1, into e power of, again x value is 1, we will be getting minus of 2. So c1 plus c2 e power of minus of 2, and this value is equals to 0 over here. Or if you just cross multiply this e power of minus 2 on the other side, it becomes 0 by e power will become 0 itself. So therefore you have 0 to be equals to C1 plus C2. Or you can write this value to be equals to C1 plus C2 is equals to 0. So let us keep this equation as it is and use the second condition. Let us take this as equation number 2. Now to get the value of y dash, I have to differentiate this equation number 1. So differentiate equation number 1. So if you differentiate equation number 1, y will become y dash is equals to. Now since x is there in the first term as well as in the second term, you have to use the product rule over here. So C1 plus C2x as it is, differentiation of e power of minus of 2x will be minus 2 e power of minus of 2x. I'm just using the product rule, u into v dash plus v into u dash. So keeping e power of minus of 2x as it is, so let us differentiate this C1 plus C2x. Differentiation of this C1 will be 0 plus differentiation of C2x. Differentiation of x will be 1. So you will just be getting C2 value. Now if you use the condition there at x is equals to 1, when x is 1 and y dash is minus of 1, then what will happen to this one? So this becomes minus of 1 is equals to, it is C1 plus x is 1, so C1 plus C2 you get, into minus 2 times of e power of x value is 1, so it becomes minus of 2 plus e power of x value is 1, you will be getting minus of 2, and this is C2. So I can write C2 e power of minus of 2. So, but we know the value of C1 plus C2 is nothing but 0. So from equation number 2 we have C1 plus C2 to be equals to 0. C1 plus C2 is equals to 0. So if I try to plug in the value over here, I will be getting minus 1 is equals to. So this becomes completely 0. So 0 into anything will be 0. So we will be left out with C2 e power of minus of 2. So we have C2 e power of minus of 2 to be equals to minus of 1. Or C2 will be equals to, send this e power of minus of 2 on the other side, becomes minus 1 by e power of minus of 2. Now this will be equals to minus of e power of minus 2, when it comes in the numerator, it becomes e power of plus 2. So let us go back to equation number 2 and get the value of C1. So from 2 we have the value of C1 to be equals to, and if I send this C2 on the other side, becomes minus of C2. So C1 will be equals to minus of C2, which is nothing but minus of, what is C2 value here? Minus e power of 2. So minus of minus will become plus, so it becomes e power of 2. So you got the value of C1 to be equals to e power of 2. So this value we can plug in back in equation number 1 in the solution. So substitute this values of C1 and C2 in equation number 1. So we have equation number 1 to be equals to C1 plus C2. So C1 value is e power of 2 plus C2. C2 value is minus e power of 2. C1 plus C2 x into, it is e power of minus of 2x. This is the solution we have. Or if I take e power of 2 outside, so I will be getting the value to be equals to, 1 is left out here, minus into plus will be minus of x will be left out, and you have e power of 2, and this will be e power of minus of 2x. Or if I try to group it over here, because bases are the same, powers can just be added. So you have 1 minus of x times of e power of, it becomes 2 minus 2x, just grouping the powers. Or 1 minus of x as it is e power of, suppose if I take 2 common outside over here, you will be left out with 1 minus of x. So that is the required solution. Let us take the next question. Solve d square y by dx square plus 4 times of dy by dx plus 5 times of y is equals to 0. Given that the value of y is equals to 2 and dy by dx is equals to d square y by dx square when the value of x is equals to 0. So let us write the differential equation in the form of the operator. So d square by dx square will be d square plus 4 times of d by dx will be d plus 5 times of y is equals to 0. So you can write down the auxiliary equation. The auxiliary equation will be m square plus 4m plus 5 is equals to 0. So you can factorize or you can use your calci. So to find out the roots, once again go for mode, choose 5, then option number 3, we'll write down the coefficients. Coefficient of m square will be 1, and then press equals to, then the next coefficient is 4, then equals to, the next coefficient is 5, then equals to. So once again you press equals to and see the root. So the root that you are getting is minus 2 plus I, minus 2 minus I. So you have the complex roots in pairs. So you are getting the roots to be equals to m is equals to minus 2, so minus 2 plus r minus I. So that will be the root of this equation. Now if you write down the complementary function itself is a solution for the homogeneous equation. So it is e power of alpha value is minus 2. So minus 2 times of x into, it is c1 cos of, here beta value, it is coefficient of I is beta. Beta value is 1. So c1 cos of x plus c2 sine of x. So that will be the required solution. Now I need to get this dy by dx value, d square y by dx square value, which means I have to differentiate this y twice. Let us take this as equation number 1. So differentiate equation number 1. Differentiate 1 with respect to x. If I try to differentiate, the derivative of y will be y dash is equals to. So because you have x in both the terms, you have to use the product rule. So e power of minus of 2x as it is, differentiation of cos will be minus sine. So minus c1 sine of x plus c2, differentiation of sine will become cos x. So u into v dash plus v into u dash. Now keeping this term as it is, you have to differentiate this one. So derivative of e power of minus of 2x will be minus 2 e power of minus of 2x. Keeping this expression as it is, it is c1 cos of x plus c2 sine of x. So once you got this y dash value, you can just try to simplify this one. If you try to observe this e power of minus of 2x, c1 cos x plus c2 sin x, this value is nothing but your y itself. So I can replace that by y so that it becomes easy for us to get y double dash. So this is e power of minus of 2x minus of c1 sine of x plus c2 cos of x. So minus plus into minus will be minus of 2, and this e power of minus 2x c1 cos x plus c2 sin x is nothing but the value of y itself. So once we have got this one, we will try to differentiate this with respect to x. So differentiate with respect to x. So y dash will become y double dash. Once again I will be using the product rule over here. E power of minus of 2x as it is, differentiation of sine will become cos. So minus c1 cos of x. Differentiation of cos will be sine minus c2 sine of x. Plus now differentiate e power of minus of 2x, you get minus 2 e power of minus of 2x. So keeping this expression as it is, minus c1 sine of x plus c2 cos of x. So product rule is complete. Next, minus 2 times of differentiation of y will be y dash. So we have obtained the value of y dash as well as the value of y double dash. Now go for the conditions that are given in the question. So given to us the value of y is equals to 2 when x is equals to 0. So let us try to plug in this value back in equation number 1. So equation number 1 will imply y is equals to, so y value is 2, so 2 is equals to, you have e power of minus 2x, so minus 2x, x value is 0, so e power of 0 will be getting, into the c1 cos of x value is 0 plus c2 sin of x value is 0. So we know that cos of 0 will be 1 and sin of 0 will be 0. So if you try to evaluate this one, this will be 2 is equals to, e power of 0 is 1. So here you have only c1. Because cos 0 is 1, this term is 0, so completely it becomes 0. So therefore we have got the first constant c1 to be equals to 2. Now to find out the value of c2, we'll use the second condition. Also given dy by dx, which is y dash, is equals to, it is given as d square y by dx square. D square y by dx square is nothing but y double dash when the value of x is equals to 0. We'll try to plug in this values of x is equals to 0 in y dash. So first I'll take the value of y dash. We already have the value of y dash, so you can just try to observe y dash value. I am trying to take y dash when the value of x is equals to 0 will be equals to. So the expression that you have is e power of minus of 2x. X value is 0, so you'll be getting e power of 0. Times of you have minus c1, sin x is there, so it becomes sin of 0. You can just observe the equation. After differentiating equation 1, you have obtained y dash, so you can just observe that equation. So c1 sin of x plus it is c2 cos of x, x value is 0. Then you have minus 2 times of e power of minus 2x, x value is 0, into you get c1 cos of x, cos x value is 0, plus you have c2 sin of x, x value is 0. So we know that this value of sin 0 is 0, cos 0 is 1, this cos 0 is 1, and sin 0 value will be 0. So e power of 0 will be 1 over here. This is sin 0, you can just ignore this. Sin 0 is 0, so here you have c2. So you're just left out with c2 here. Coming to this term, this is 0, you can ignore it. This is 1 here. So c1 you have. So you can just multiply minus 2 times of c1, minus of 2 c1. So that is one of the equation you have. So let us take this as equation number 2. Then also let us use the condition for y double dash. So you have y double dash also, you can just observe. Also I'll be using y double dash. So y double dash when the value of x is equals to 0. So y double dash, you have the equation as, just observe the equation, e power of 0 times of, it is minus c1, you have cos of x value will be 0, minus c2, you have sin of 0. The next term that you have is minus 2 times of e power of minus of 2x, e power of minus of 2x will be 0. Then you have minus c1 sin of x value is 0 plus c2 cos of x value is 0, minus it's 2 times of y dash when the value of x is equals to 0. We try to simplify this one. This e power of 0 is 1 and cos of 0 is 1, so we'll be getting minus of c1. This becomes 0, you can ignore it. Then minus of, you have 2 times of, e power of 0 will be 1, sin 0 will be 0, you can ignore this one. Cos 0 is 1, you're left out with c2. And here minus 2 times of y dash at x is equals to 0 is already there over here. You can just plug in that value to be equals to c2 minus 2 times of c1. Simplify this one, you have minus of c1, minus of 2 times of c1, minus 2 times of c1, minus of minus will become plus 4 times of c1. So you can just group the like terms. So 4c1 minus c1 will be 3 times of c1, Here minus 2c2 minus 2c2 will be minus 4 times of c2. So let us take this as equation number 3. So it is given that the value of y dash is nothing but y double dash when x is equals to 0. It is given that y dash is nothing but y double dash when x is equals to 0, which means this y dash value, the left hand side values are the same. If the left hand side values are the same, you can equate the right hand side values. So therefore, equating 2 and 3, equations 2 and 3. We will try to equate equations 2 and 3. So if you equate equations 2 and 3, equation number 2 you have it is c2 minus 2 times of c1 is equals to, you have 3 times of c1 minus 4 c2. So let us try to group the like terms over here. Let us take all the values on the left hand side. You have c2 minus 2c1 minus 3c1 and minus will become plus 4c2 is equals to 0. So you have over here minus 2c1 minus of 3c1 will be minus 5 times of c1. And here 4c2 plus c2 will be 5 times of c2 is equals to 0. Or suppose if I take a minus of 5 outside here, we will be left out with c1 minus of c2 is equals to 0. Or if I divide the equation by minus of 5, so 5 will cancel out, we will be left out with c1 minus c2 is equals to 0, which is nothing but c1 is equals to c2. But what is the value of c1? But c1 we have got it as 2. So if I try to plug in this value here, c2 is c1. So c2 will also become 2 itself. So we have got c1 and c2 to be equals to 2. So if you substitute these values, therefore substitute c1 c2 to be equals to 2 back in your equation number 1. So which is y is equals to, we got the equation to be e power of minus of 2x into, you have c1 value is 2, so 2 times of cos of x plus c2 value is 2, so 2 times of sin of x. So suppose if I take 2 common outside, it will become 2 e power of minus of 2x into, you have cos of x plus sin of x. So that is the required solution. That's all I have for today. Thank you.